The next question says, in the experiment on photoelectric effect, the graph between Ek max, which is kinetic energy max, and nu, which is frequency, is found to be a straight line as shown in the figure. There is a graph which is given in the question, and they have asked the threshold frequency and the Planck's constant R. Now if you remember the graph of Ke max versus frequency, the point where it cuts the x-axis was the threshold frequency, and the slope for this graph is h, Planck's constant. Now using this known fact in the question, I can say the threshold frequency is 2 times 3 into 10 raised to 14. Now how this thing came into picture, please pay attention to the graph in which it shows on the x-axis as nu into bracket 3 into 10 raised to 14, which means all the numbers which are mentioned on the x-axis are to be multiplied by 3 into 10 raised to 14 to get the value of respective value of frequency. So this becomes 6 into 10 raised to 14 per second, which is the final answer. Now we are supposed to find the slope. Because the slope is Planck's constant, we can say the slope can be determined by y2 minus y1 upon x2 minus x1. Now in the graph, I can say y2 is going to be 3.6 and y1 is going to be 0, for respective x2 to be 6 and x1 to be 2, commonly multiplied by 3 into 10 raised to 14, and the numerator commonly multiplied by 10 raised to minus 19. Please understand, again on the y-axis it is represented to be multiplied by 10 raised to minus 19 with all the numbers, and on the x-axis it is represented to be multiplied by 3 into 10 raised to 14 with all the numbers. Now substituting this value, we get this as 3.6 into 10 raised to minus 19 upon 12 into 10 raised to 14. Now calculating this, we get the slope or the Planck's constant as 3 into 10 raised to minus 34 joule second. Now many of you must be wondering that the Planck's constant, generally the value is 6.63 into 10 raised to minus 34 joule second. But please understand over here that in this question, it is a hypothetical situation which is given to you, for which the Planck constant is to be calculated. So assuming the value of Planck's constant is not allowed. So please calculate the slope, and using the slope, the value what you get is the value of Planck's constant which you use for that particular question.